Today we're going to be looking at the rational function parent function and some simple transformations of the parent function using the transformation rules that we're familiar with from last unit. So our parent function is y equals, or f of x equals 1 over x. So without graphing it, how could we determine its domain? So remember, domain are allowable x values. So I think that you remember you can't divide by 0. So our domain would be x can never equal 0, or it will make this function undefined. But x could be anything else. So x could be a negative number, x could be a fraction, a decimal, a positive number. So now we're going to graph the parent function, but we're going to make a table of values first. So to help us find some key points. So if I take 1 and divide by -2, I would get the value -1/2. If I take the value of 1 and divide by -1, I would have a value of -1. What if I divide by a fraction? So a number that's divided by a fraction, so in this case we're dividing by -1/2, the rule is that you flip over, take the reciprocal of the denominator, and multiply. So this is like multiplying by -2 over 1. So 1 divided by -1/2 is actually the value -2. And 1 divided by the fraction -1/4 is actually the value -4. And if you forgot how to do that, you could just take 1 and divide by -1/2 on the calculator. There's your answer, -2. 1 divided by -0.25, there's your answer, -4. So, and we already said that when you divide by 0, the answer will be undefined. So what about if I take 1 and I divide by 1/4? Now I would be at +4. Take 1 and divide by 1/2, I'd be at +2. Take 1 and divide by 1, +1. Take 1 and divide by 2, +1/2. So I'm seeing some symmetry on either side of the graph, similar to a parabola has symmetry. All right, so when I plot these points, -2, -1/2, -1, -1, -1/2, -2, and -0.25, -1, 2, 3, 4. So this is actually a curved shape of a graph that's down here in the third quadrant. And now when I do undefined, that's actually a vertical asymptote at x equals 0. That's kind of hard to see, but this is an asymptote. So it's a line that the graph is going to approach. So it's going to get closer and closer to that line as it goes down here. So then I'm plotting at 1/4, I'm at 1, 2, 3, 4. And then at 1/2, I'm at 2. At 1, I'm at 1. And at 2, I'm at 1/2. So this is an L-shaped graph that's up here in the first quadrant. So it's very symmetrical in both quadrants. One other thing to notice, there's another asymptote at y equals 0. So the graph never actually touches the x-axis. It's going to get closer and closer and closer and closer. But if you're getting 1/2 and then 1/4 and then 1/8, your fraction is getting smaller and smaller, but you're never reaching 0. So this is the parent function of the rational function. So determine the end behavior. So when I look at this function, what is the end behavior of the graph? So there's a couple different ways we can talk about end behavior, but as my x value approaches positive infinity over here, the right end of the graph, what does the function do? The function f of x approaches 0, right? The y values approach 0, right? So that's my first end behavior. So that is looking at this end of the graph. So what about when I look at the other end of the graph over here? So what about as x approaches negative infinity, so the left side of the graph? What is the function approaching? It's also approaching 0. All right, so there are actually two other ends of the graph that I didn't talk about, so I should have given myself a little bit more space here. But what is happening when the x value approaches 0? So there's another little piece to talk about. So as x approaches 0 from the left, the way that we can write, so another way I can write this, x is approaching 0 from the left, the negative side. So what's happening to my function? As x approaches 0 from the left, the function is approaching negative infinity, right? It's going down, 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 down. So the other end that I should have talked about was, what about as x approaches 0 from the right? X approaches 0 from the right. What's this side of the graph going? This side of the graph is pointing straight up. So f of x is approaching positive infinity. So these two down here are really new ideas approaching an asymptote. So I just wanted you to be exposed to those ideas. Up here is what you really need to know, right? What's the end of this graph doing? It's approaching 0. What's the range of this function? So when I scan the y-axis, are all of the y values being used? Well, y can never get to 0. So my range is everything except y never equals 0. Similar to how my domain x was never equal to 0, because it also had an asymptote. So this last part, let's see. Rational functions are one type of function that has asymptotes. An asymptote is a line that a curve approaches as it heads toward infinity. What asymptotes do you see, and how do these relate to the domain and range? We've kind of already talked about that, but x equals 0 was one asymptote, y equals 0 was the other asymptote, and they are directly related to the restrictions in the domain and range. So these were the actual asymptotes. All right, so we are going to look at together how to transform these functions with some simple transformation rules. And today I'm going to just do a video of this whole paper, and you're just going to send me a picture of the back page here so I know that you did it. But these are a little bit more challenging, so I wanted to do them together today. All right, so transformation rules we already know. For each function, identify the transformation and sketch the graph. Give the vertical asymptotes, the domain and range, and plot at least one point on each curve. So when there's a -1 with the x value, that tells us to go right 1. When there's a plus sign outside the function, that tells us to go up 2. So we think about that parent function from the front page had a vertical asymptote and a horizontal asymptote. Those asymptotes are just going to get shifted. So if I shift right 1, my asymptote itself is actually going to shift right 1. If I shift up 2, the asymptote itself is actually going to shift up 2. And what other key points did we have? So the key points that we had were 1, 1 and -1, -1. So let's shift those 2 points. So if I originally had 1, 1 and -1, -1, and I'm going to shift those points up 2 and to the right by 1, up 2, right 1 puts me right here. So there's the top part of my graph. Up 2 and right 1 puts me right here. So there is the other L-shaped part of my graph. So it's basically just shifting the parent function from the front page, shifting the asymptotes and those 2 key points, right 1 and up 2. So what transformation rule do you see in part B? I see that this is going to go to the left by 3, and it's going to go down by 1. So left by 3, I'm going to move my asymptote left 3. 1, 2, 3. So my new asymptote will be at x equals -3. down 1, so my new asymptote here is going to be y equals -1. And if I move those key points, right, I was moving 1, 1, and -1, -1. I'm moving them left 3, 1, 2, 3, and down 1. So there's my new key point. And if I go left 1, 2, 3, and down 1, so basically wherever your little intersection cross is, that's kind of like the new origin. So your points are 1 away from that in either direction diagonally. Oh, and I was supposed to discuss the asymptotes and the domain and range. So what is the domain of this function? So I can have every x value except -3. So x cannot equal -3. And I can have every y value except -1. So y can never equal -1. Let's go up and repeat the same domain and range up here. So my domain, x can be every value except my vertical asymptote. My vertical asymptote was at x equals 1. So my domain is x does not equal 1. My range is all of my y values except my asymptote, which was at y equals 2. So my range is y does not equal 2. So let's do this last one together. All right, so I have a couple transformations this time. This is going to shift me down 3. This is going to shift me left 1. And this is going to flip me over the x-axis. All right, so let's worry about these shifts first for our asymptotes, and then we'll do this one second. So down 3, 1, 2, 3 is here. And left 1 is here. All right, so I know that my normal key points are 1 box diagonally in this direction and 1 box diagonally in this direction. But if I'm flipping it over the x-axis, instead of doing this point, I'm going to graph this point, and it's going to be flipped upside down like that. And instead of graphing this point, it would have been flipped upside down. And so another thing you can be doing if you're struggling with this virtually, always check your answer on your graphing calculator. Make sure that it makes sense. So let's talk about our domain and our range. So our domain, here's my asymptote at -1. So x itself cannot equal -1. Here are all my y values. My asymptote was at -3, so my range is y cannot equal -3. So all you need to do for today to get credit is take a picture that you completed the back page of your notes. I'm hoping that you followed along and listened, so some of this is starting to sink in, and you can post your picture on Google Classroom today. Thank you.